All right, guys, so we've been talking about logarithms and exponentials and how they correlate and go back and forth. And what we're going to be talking about today is three main properties of logarithms, and they can go in either direction. And the first main property is our product property, which tells us if I have log base b of m times n, and m times n is inside the logarithm, is equal to log base b of m plus log base b of n. We can split them apart. We can split them apart inside the log. Or if I have two logs with the same base that are being added together, we can put them back together with multiplication, with those being multiplied inside. The same thing is true with our quotient. If I have two things being divided inside of the logarithm, we can split them up with subtraction. And our power property, log base b of m to the n, bless you, is equal to n log base b of m. We can move that exponent out front. Any questions on any of this here so far? We good with this here so far? Yes? Now, it really works out that the product property, the power property is actually derived, or we can get it from the product property. And the quotient property is really coming from the power and product property being used them together. Because if we look at the quotient, or the power property, log base b of m to the n. Well, anything to a power is just telling me I'm multiplying, bless you, m by itself n number of times, yes? Because it's being multiplied again and again and again. Now, if we say that the product property is true, that anything where we have more than one thing multiplied together, we can rewrite it out as addition, is really telling me that this here is the same as log base b of m plus log base b of m plus continuing on n number of times because I have n amount of m, yes? Well, so I have n of these, and they're just the same thing all in common, yes? So I can factor it out. If I factor anything out of itself, I'm left with 1, yes? Plus 1, plus 1, plus n, because it's going to continue out to, because we have a number of them. So it'll be 1 plus 1 plus 1 plus 1 going all the way out to whatever n is, number of them. So really, this here, well, we wouldn't really say that that's n. We'd say that this number of ones is n, whatever the power is. So really, this is the same as saying n log base b of m. Now, realistically, this would not be a rigorous proof or showing of this, but we can kind of see with this here, okay, with the fact that our product property, we can show that the power rule works, and whatever the exponent is, we can move it out front, because really, it's just saying we're adding that to itself x number of times. And the power rule is kind of the same way. If we know that or quotient, if we know that the, I'm not talking, product and power rule work, quotient works as well. Log base b of m divided by n. Because as we've worked with this sum already, I can move into the numerator and change the exponent from positive to negative because we get negative 1. Because we moved it from the denominator to the numerator. Well, according to our product, I'd have m plus log base b of n to the negative 1. Because I just have two things multiplied together. But our power rule says that I can take that negative 1 and move it out front. which really just tells me that I have log base b of m minus log base b of n, which is our quotient rule. So these here, really, I'm just walking through these, kind of showing you how we can get each one, and they come from each other. Now, for the most part, these are actually quite helpful because we can expand or condense logarithms. And it's really helpful, especially when solving, and I have more than one logarithm, to put them back together, because they work a little bit better when I have one of them instead of 6. Now, to work with these properties here, we're going to evaluate each log given that log base 2 of 3 is 1.585 and log base 2 of 7 is 2.807. Yes, sir. Yes. Now, this here, we've gone over how we can actually plug these into the calculator. We went over that on Friday. But instead of plugging them in, we're going to use these properties to help us solve. Because 3 is being divided by 7 inside of the logarithm, and it can't be 2 logarithms being divided. That does not work the same way. I can rewrite this as log base 2 of minus log base 2 of 7. We can split these up into subtraction because 3 and 7 are being divided inside of the logarithm. Any questions on this so far? Now, it told us log base 2 of 3 is 1.585. So this here is 1.585. Log base 2 of 7 is 2.807. All right. Well, what do we need to do next? We just need to subtract the 2. Negative 222. Okay. So it should be.
I did the log.
Yep. Oh yeah, because okay. Oh, you're wrong. But that's it. That's it right there. That's all we have to do for these here. Any questions on this here? So let's look at another one. Log base 2 of 21. Now we're going to go on and use the properties of logarithms. And this one here, well, 21, we really want to write 21 using 3 and 7. So how can I rewrite 21 using 3 and 7? Because 3 times 7 is 21. And now I have a multiplication inside the log, which can be rewritten as addition, because we can do log base 2 of 3 plus log base 2 of 7, which is the same as log base 2 of 21. Well, log base 2 of 3 is, as we said, 1.585. And log base 2 of 7 is 2.807. And this time we're going to add them together. That's 5, 4, 3, 9, 2. Yep. Yep. Any questions on any of this here? Now this is one thing that does come up on the ACT, dealing with logarithms, simplifying, expanding, dealing with these here. Bless you. Any questions on any of this here so far? Log base 2 of 49. How can we rewrite this? Mm-hmm. 7 times 7, or we can say 7 squared, because we can write it in either form. Now 7 squared is a little bit easier to work with because I can take this exponent of 2 and move it out front, which really tells me that I have 2 log base 2 of 7. The log base 2 of 7, as we know, is 2.807. So we just need to multiply this here by 2. 14. Be good if y'all check that, just to make sure. I believe it should be 5.614. We agree with that? And that's it. That's all we have to do for these here. And really, when we worked at logarithms before we had a calculator that could rigorously calculate these, this is the main way that you would actually solve them. Instead of us, because we would have, there's logarithmic tables, especially with different bases, that you can have in reference. So what you would try to do with these logarithms would break it down into some of those forms, use the table, substitute those in, and do the addition and subtraction calculations. So are there any questions on how we do these here? Or do we feel comfortable with expanding these out and simplifying? Yes? Well, if that's the case, let's move on. Because if y'all feel comfortable with these, there's no point in doing tons and tons and tons of them. Let's look at this here. Now this here, we're not going to get a definite answer like we did on the last few. We're not going to get a number like 5.608 or whatever we got on the last one for log base 2 of 49. We're not going to get just a number. We're going to get a list. Because when we look at this here, we want to expand as far as possible the natural log of 5x to the 7th divided by y. So what we want inside of each logarithm or natural logarithm is a term. So be it a number or a variable, we want it by itself, and we do not want anything with exponents. We want everything as simplified as we can possibly get it. So when we look at this here, really the first thing I look for is multiplication or division. Those are the first things I'm looking for. We're going to always deal with exponents last, multiplication and division first, division going before multiplication. So when we look at this here, well, there is two things being divided, yes? Because we have the numerator and we have the denominator. So according to our properties, we can rewrite division as subtraction. Numerator being divided by the denominator. And it doesn't matter that the numerator has more than one term. That entire numerator goes together. This is why I do division first, because it gets a little tricky if we try to do multiplication before it. Numerator divided by denominator gets split. Any questions on this here so far? So we don't have any more division in any of the sets of parentheses, but we do have multiplication, yes? Because we have the 5 times x to the 7th. Well, any multiplication inside of a logarithm can be rewritten as addition. So we can split up the 5 and x to the 7th, which gives us the natural log of 5, plus the natural log of x to the 7th. And then we still have our subtraction of the natural log of y. Yes, because x is to the 7th, our power property says I can take that 7 and move it to the front. Which tells us that I have the natural log of 5 plus 7 natural log of x minus the natural log of y. And that there is as far as we'll take it because there's nothing else we can do. It is expanded as far as we can possibly have it. 5 is as simplified as it gets, x is as simplified as it gets, and y is as well. And that's it for this here. Questions on this here? Now, the properties of natural log, we didn't have them written out, but are the exact same as logarithms. They will share the same properties. Because the natural log, the only real difference between the natural log and a log is that its base is what? E. It's understood to be E. Natural log is just a logarithm with base E. Okay. So looking at this one here, what can we do first? We would separate the division. So we'd have the natural log of 3x to the 5th minus the natural log of y. What would be next? We would split up the multiplication with our 3x to the 5th, which would give us the natural log of 3, plus the natural log of x to the 5th, minus the natural log of y. And then, yes, we would move the 5th power to the front, giving us 5 ln of x minus ln of y. And that would be it. Any questions on any of this here? Any questions on anything we've done so far? Okay. Let's look at the next one. Let's look at number 5. So looking at problem number 5, what can we do first? I would not put the 4 in front first. I would put it in front if it was being applied to the 3 and x to the x. Because if we had log base 6 of the quantity in parentheses 3x to the 4th power, then I would do the 4 first because it's affecting both the 3 and the x. Now because this here, it's only affecting the x, we want to split them apart first. So we would have log base 6 of 3 Since they're being multiplied together, we can rewrite them using addition. And then we'd move the 4 in front. Any questions on any of these here so far? We good with these here? Okay. Let's look at this here, number 6. This one here is a little bit different than ones we've done so far because we have how many terms in the denominator? 2. Because this is the first one where we have 2. Now, we can still do our same properties because we'd have ln of 5 minus ln of 12x. Because that one doesn't change. We're still doing subtraction, and we have this here. Now we can rewrite ln of 12x as what? Ln of 12 plus ln of x, yes? But what we need to be careful of is we need parentheses around this here. We need parentheses around this here because that negative does go with the 12 and with the x, yes? It's going with both of them. So if we're not careful and we just write this as ln of 5 minus ln of 12 plus ln of x, we don't apply that negative to the natural log of x, it will give us something different. So really, if I redistribute or multiply through by this negative 1, we have negative ln of 12 minus ln of x. Because for both of those to be in the denominator, they both have to be negative. Bless you. So any questions on any of these here? Any questions on anything we've done thus far? Okay. Now the next step, or the next thing that we're going to cover is going the opposite direction. Because so far, we've been expanding. The next problem tells us to do what? Condense. So we're going the opposite direction. So up to this point, we've been getting multiple logs where each term inside of the log is as simplified as it can get. Can't get any simpler, can't use any other properties to reduce it. Now we're wanting one log or one natural log with everything inside. And this here, where we have multiple negatives, would normally be a little bit tricky because depending on how you approach it. But the way I look at it and kind of work through it, we'll go through it and we'll see it's a little bit easier. Because one of the things that we could do, the pure math way to do it, is to group all the ones that have subtraction, all of the ones that have that negative out front, together, pull it out like we had at this point here so that we can see that division. But there's another way we can do it. So we want to condense this here. Now the only way that we can condense multiple terms is if their bases are all the same. If we have different bases, we're not able to combine them or use any of these properties here. But for this one here, we have 3 common logs. All the bases are 10, so we can combine them how we want. Now the main way that I go with this here is kind of the opposite direction of how we pretty much expanded it. Because when we expanded it, we really started off with division, then went with multiplication, and lastly we did exponents. So for this here, we're going to start off with exponents, then do multiplication, and then we'll be almost done. We just have to simplify some powers. Now when we look at this here, I'm going to treat negatives as being an exponent. And that's really going to help us with the division property. So when we look at this here, log base, or log of 9, well, there's nothing in front of it. It's positive. So we're good. We can't really do exponents with log of 9. But our middle one, plus 3 log of 2, we do have an exponent of 3 that we can use. So we're going to have plus log of 2 to the third. Does log of 3 have an exponent in front of it, or a number in front of it that we can make into an exponent? Well, it doesn't have a number, but it does have the negative, yes? I'm going to pull it up as well. Log of 3 to the negative 1. Now this here is how I found to be the easier way to deal with our division property. Because normally what we'd want to do is try to group everything that would be negative out front and try to deal with it that way. This here, especially once we combine everything, Well, if a number or variable has a negative exponent, we move it from the numerator to the denominator or denominator to the numerator. Well, doing that move takes care of any exponents or any division type properties that we could come across in a more streamlined and simplified way. Let's look at this here. I have 1, 2, 3 things being added together with the same base. So it's the same as saying log of 9 times 2 to the third times 3 to the negative 1. Because I had several logs added together that have the same base, I can rewrite it as 1 with each of the things inside the logarithm being multiplied together. Now we're almost done with this here. Any questions before we move on to the next step? Now the 3 does have a negative exponent, but we can't leave exponents negative. So to make it positive, we have to move it from the numerator to the denominator. Any questions on any of this here? Can we simplify anything that's inside that log? Will 9 over 3 simplify? 9 divided by 3 is 3, yes? What is 2 to the third? Can I take 3 times 8? Which is? Now, because they were all numbers, we had 9, 2 to the third, and 3 in the denominator. Since they're all numbers and I can simplify them, we're going to go on and simplify them. In the book, especially on the homework, when it asks you to condense, especially problems like this here, it's wanting this. Now, especially with this being common logs, if I wanted to check my answer, you can. Because log of 24 is a number, yes? I can type it into a calculator and get a number answer, a numerical answer. So I can type that in and see what I get. I can also go back and type in log of 9 plus 3 log of 2 minus log of 3, hit enter and see, do I get the same thing? Because if I do, then yes, those are the same answer. If I don't, okay, something went a little awry. Any questions on this condensing here? Let's look at this next one here. We want to condense log of 6 plus 4 log of 3 minus log of 3. Well, we can't do anything. Yes. We can't do anything with log of 6 because, well, at least power-wise. We're going to start off with the power rule, then move to multiplication, and then simplify. Because luckily, when we're pulling those negative exponents into the numerator, we don't have to worry about the division property. Now with our power rule, well, log of 6 is not going to change. We don't have any negative exponents out front or any numbers out in front of the log, so it stays the same. But 4 log of 3 is going to be rewritten as log of 3 to the 4th, because we can pull that 4 up into an exponent. And our negative log of 3 would become plus log of 3 to the negative 1, because we can pull that negative up into the exponent. Any questions on any of this here so far? Well, since I have 3 things being added together, we can rewrite them as multiplication. So we'd have 6 times 3 to the 4th times 3 to the negative 1. 3 logs with the same base being added together, we can rewrite as multiplication. Now at this point here, there's several routes we can go. One of the roots is, since 3 is being one of the 3's is to the -1, I can move it from the numerator to the denominator to make that exponent positive. But we also have like bases being multiplied together, yes? Because when I have like bases being multiplied together, what do we do with the exponents? We add them together. So we could do either one, and we would get the same result. Because if I add those exponents together, 4 plus -1 is 3. Because if I moved it to the denominator, one of them would simplify out, which would still give us 3 to the third. Now, what is 3 to the third? Because 3 squared would be 9, and 9 times 3 is 27. And last but not least, we need to do 6 times 27. Mm-hmm. 162. Now, really, we could have typed into the calculator 6 times 3 to the third, and it would have given us our answer. Either one of them would work. We don't have to just work it out this way here. Any questions on any of this here so far? Any questions on any of these here so far? Because as I'm looking at this here, this one and the next one are the exact same as what we just did. The numbers are a little bit different. So do we feel comfortable with this here? Yes? Okay. And these here are no different than what we've been doing. So are there any questions on any of these here so far? So no matter how complicated or how many terms we throw into these here, expanding and condensing, as long as we go one step at a time and deal with these one step at a time, they're not as bad as we might think. Any questions on this here? Now, as I talked about this on Friday, because plugging them into the calculator, as we saw, I can't just use the log button to do log base 7 of a logarithm. Because if the base of a logarithm is not 10, it is hard or difficult for us to be able to actually calculate them without using log base in the graphing calculator. But there is something called the change of base formula. And this formula here lets us change the base from any other base besides 10. You don't want to use this on base 10, because if it is already base 10, it doesn't really help us out, because that's what we're trying to do, is we're trying to get it into these common logs. And it works out that log base C of A is equal to log base B of A over log base B of C, or log base 10 in particular. So log base C of A is the same as log of A divided by log of C, which is actually the same as the natural log of A divided by the natural log of C, because the bases are going to be the same. So if I look at this here, log base 3 of 8, if I wanted to rewrite this as common logs using change of base, what would we have on top? Log of 8 over log of 3. We rewrite it as division. We have log of whatever's inside the logarithm to start with. So since it's 8, we'd have log of 8 over log of the base, which would be log of 3. Any questions on this so far? Now, how would I write this with natural logs? ln of 8 over ln of 3. It will actually give you the exact same thing. Any questions on any of this here? Log base 7 of 11 would be over log of 7. Because we always want the base to be on the denominator. When we plug the base in, its number is going to be on the bottom of the fraction. Base number is always going to be on the bottom of the fraction. And for natural logs, this would be ln of over ln of. So this here is helpful, especially if you only have the TI-30XS, or you have a calculator that does not do log base, where you can type the base in specifically. This here gives us a way to use common logs base 10, be able to evaluate these. Questions on this here? Let's do one more because I feel like y'all are getting the hang of these. You like these here, these change of base. Yes? Hopefully y'all won't miss a single one on the test. Yes. So this here would be log of 24 over log of . And that's all we'd have to do for these here. Now these here specifically ask for the natural logs, but especially on the test, I will ask for both. Rewrite it as common logs and natural logs, and that's all it's asking for. Any questions on anything we've done so far? And that's it. That's all we have for today. Yep, it's on the other side.